Welcome to Math Dive in 5, Grade 3, Unit 7 on multiplication strategies. My name is Daryl Frost.
And I'm Barbara Knox. Welcome.
On the next slide, you're going to pause this video, and on the next slide, you're going to solve a problem with either your team or a partner or by yourself. We're going to ask that you utilize base 10 blocks to support making sense of the problem. And as you are working through the task, at the bottom of the slide, you will see 3 questions that we would like for you to reflect upon as you engage in the problem. So we'll see you back in just a minute. So let's take a look here at the progression with BEST. In second grade, and this is not new, second graders have worked with repeated addition and rectangular arrays, thinking about rows and columns and writing equations to represent those arrays.
And they're still not using the multiplication symbol in second grade with BEST.
Correct, yes. No, it's just that foundation of understanding repeated addition. Thank you for saying that, Barbara. And then you take a look here at third grade, they're working with factors now to 12 and focusing on, by the end of third grade, having a reliable procedure to solve those basic fact problems. Moving into distributive property, and applying properties of multiplication to find a product of one-digit whole numbers. And then in grade 4, notice the language of recall with automaticity for those basic facts to 12.
Are you sure, Daryl, that that is in third grade, multiplying a one-digit number by a two-digit number?
It sure is. And if you watch the Maths to Best video for this unit, that's what's highlighted, and so that's why we're highlighting that here in our Dive in 5.
New learning for third
new
grade.
learning for third grade and for teachers on how to facilitate it.
Right.
Yeah, very good. I'm glad you mentioned that. Okay, so let's take a look here. We're going back to that lettuce plant problem that all the teachers solved here. What do you see here, Barbara?
I see a bunch of base 10 blocks, Daryl.
Yes, and I'm sure all the teachers did something like this because they did solve this with base 10 blocks here.
But we do want to make sure that our students are contextualizing what those base 10 blocks represent.
So like, where are the lettuce plants
Right.
here? So thinking about these questions here at the bottom, let's go through each one and just kind of go back and forth and come up with some questions. What questions would you ask to connect the story problem to the area model?
Where do you see a lettuce plant?
And I would expect them to say, well, I see an individual in there in that array, that 3 by 3 groups of 3.
So if those yellow blocks are representing an individual lettuce plant, what do the blue blocks represent?
Oh, 10. Or maybe
10.
I have to put 10 cubes on top of that one of those rods to see, oh.
Well, and I think if this is the first problem you're using for two-digit times one-digit multiplication, I might have them initially build it with unit cubes. So I have 43 individual rows. I have 43 rows of individual lettuce plants, 3 plants in each row.
That's a great instructional practice because depending on the student's readiness level for this, they may not see that rod is 10 plants that they need to build that.
And if I push that together to make a rectangle, a solid rectangle, I can then take the 10 rods and start laying them on top of those unit cubes.
There you go.
So I could replace these 10 unit cubes with a 10 rod. And
Absolutely.
looking at that first row of 3 10 rods, I know that I really have 30 plants because there's 10 plants in each of those blue sticks.
And thinking about all that kind of lends them to understanding what an area model is.
Yes.
Then, right? That I've got length and width, and I can see partial products there.
Correct.
What partial products do you see there, would you want a third grader to say?
Well, I might see 10 rows of 3, 10 rows of 3, 10 rows of 3, 10 rows of 3, 3 rows of 3. I might see 20 rows of 3, 20 rows of 3, 3 rows of 3.
Listen to that flexibility, and I would think that helps students build fluency with facts
And
as well.
eventually we want them to get to where they can see 40 rows of 3 and 3 rows of 3 using that distributive property, breaking it into tens and ones.
And maybe even something like this, based on what you just
Oh.
said. Look at that. I could draw a box or a rectangle
Around the tens.
around the
and
tens and the ones. And then what do you see
Oh,
here?
wow, that's an open area model.
There you go. And that's what we want students to be able to do, but we can't start
So
here.
how would you label that open area model, Darren?
Well, I would do something like that, where I see my 40 groups of 3 with all those rods, and I see
Okay.
my 3 groups of 3 with those individual lettuce plants.
All right.
Make sense?
Yes.
What about challenges or misconceptions with solving a problem like this?
Well, I think that in the open area model, some students may see 4 rows of 3 and 3 rows of 3, not considering that that 10 rod is actually 10 lettuce plants.
So a place value misconception.
Place
could be-
value misconception, and also going back and forth between the context and the numbers,
Yes.
right?
So it's important
And
that we put,
knowing what those numbers represent. What does that 10 rod represent?
yes,
It
and
doesn't
it's
represent one plant, it represents 10 plants.
So it's important to take it back to the context of the
Yes.
story. All right, thank you.
Yep.
So as we move along the continuum of the CRA process, we want students to start using representational models such as what we saw that open array.
But they're probably not going to leap to the open array first.
They probably will do something like this.
Quick picture.
A quick pick of doing like those sticks, which would represent a rod. They don't actually have to draw the rod with a segmentation.
No, and I think it's really important here when students are using this quick picture for them to understand that that stick that they drew still represents 10 lettuce plants.
Absolutely.
You know, when I have the 10 rod sitting in front of me, I can see the 10 partitions on that 10 rod, but I
Yes.
can't see it on my stick.
So we have to ask questions to connect.
Yes.
You know, where do you see the 10 lettuce plants from the base 10 model to this model
Right.
here? And you see that language there, those two sentences. That's important language for students to be able to verbalize
Yes.
by asking a question. Well, you know, what do the rows represent? What do the columns represent? And again, you know, asking questions to connect the models.
Yep.
You know. So moving along the continuum of CRA, we want students to start developing understanding of abstract models. So, and we need to, again, we have to ask questions, connecting questions to connect concrete models, representational models, and abstract models here.
Yeah, they have to understand how they all work together.
So if you take a look at this here, we see those base 10 blocks. Then we see here, if we think about what that standard is, the distributive property.
And I mean, I can visualize the open area model that we made for that array, and I can see that that rectangle went around my 40 rows of 3 and my 3 rows of 3.
And you said something very important, Barbara, that we want third graders to do, and that's visualize.
Yes.
Once they've built these models and with some practice and understanding, they can start visualizing those models.
Sure can.
And then they can write something abstractly. I can see how I broke up that 43 into tens and ones.
And that standard algorithm that we see on the far right isn't actually part of third grade standards, but you're going to have some students that come to school. My parents have showed me how to use this, and this is how I make sense of it. But we want to make sure that they can tie it back to the models that they've been creating.
Like
Where do I see the 40 rows of 3? Where do
Yes.
I see the 3 rows of 3? What does that 9 represent? What does the 120 represent? And it's not going in the same order that it did when we did the distributive property. We started with 40 times 3, but in the standard algorithm, they're starting with 3 rows of 3.
And that's what an algorithm is. It's a step-by-step
Yes.
procedure, but like you said, it's important for them to understand.
And be able to connect back.
So this is just a recap. We've talked about place value as a potential misconception. With this particular benchmark, students will struggle with understanding place value with tens and ones with 2-digit factors. And you see there are 3 different ways that you could address and help students get across that hurdle. Another potential misconception would be decomposing factors strategically, So you see 4 groups of 26 there and 3 different ways that could be done.
And really our goal here is to move from the less efficient strategies to the more efficient strategies. It's not incorrect to break it into 10, 10, 5, and 1, but it's much more efficient to break it into a 20 and a 6.
Yes, and that's where you could have some good conversation with partner talk with kids
Right.
about how we got the same product, but oh, you did it. Yours
And
is
as
quicker.
a teacher, I should be strategically looking around the room to see how they're breaking it apart and bringing up some of those models and talking about efficiency.
Exactly. So to recap the CRA process, we begin with concrete thinking, like for example, the base 10 blocks, moving to representational thinking where you see an exact duplicate copy of those base 10 blocks, then moving to an open array, which then leads to the distributive property. And as we had spoken earlier, if students are coming in using the standard algorithm, they need to have understanding. It needs to be deep rooted in
We need to help
conceptual
them
understanding.
make sense of
So
that
right.
algorithm. And also, I think it's important to make connections back and forth between all of those models. So when I am working with the algorithms with either the distributive property or the standard algorithm, I want to take it back to maybe the open area model. Where do I see the 120? Where do I see the 9?
And you're going to have to do that back and forth. That's why that bridge building, it's not just,
Yes.
Going across at once. You got to go back and forth between the
Exactly.
islands. We hope this dive in 5 has been helpful to you on teaching 2-digit by 1-digit multiplication.
Thank you for joining us. See you next time.
Bye.